Okay, we're going to look at some tutorial questions. So this is the first of the tutorial questions. Essentially what we're going to be doing in this presentation is looking at a series of definite and indefinite integrals and evaluating them. This is a definite integral. The limits are 1 and 0. Dx divided by 3x plus 2 squared. This is what we're going to use here is the substitution technique. So u equals 3x plus 2. We're going to let du dx equals 3, just differentiate that. Let's get an expression for du dx. So du is equal to 3 times dx. In this particular instance, we're going to use this further simplification. 1/3 du is equal to dx. So let's go back to our integral. What we can do is take the 1/3 out. Okay. So we have taken care of the 1/3. Replace dx with du because we've already taken care of the 1/3. It's du there. And what we have here is 1 over u squared. Now, what I'm going to do is quickly, I'm going to rewrite that as u to the power of minus 2. Okay. Now, integrating that, we get 1/3 by u to the minus 1 over minus 1. Okay, plus c. Okay. This minus 1 we can take out, put it over here. Essentially, multiply through by minus 1, and that minus 1 just cancels out. So we have minus 1/3 of u to the power of minus 1. Essentially our answer is minus 1 over 3u plus c. Okay. So let's put in our values again. So 1/3 or minus 1 times 3u we just leave the coefficient for a second. So that is equal to 1 minus 1 over 3 into 3x plus 2. Okay. Plus c. Okay. Now let's evaluate it for our definite integrals. We can work that out. It's 9x 9x plus 6. Just let's simplify that. 9x plus 6. Okay. So let's evaluate it for our definite integral. Our limits. So the top limit was 1, the bottom one was 0. Okay. So we have minus 1, 9x plus 6 when x equals 1, that's 15, minus 1 over 9x plus 6 when that is x is equal to 0, that's just 6. The minuses cancel out, so it's minus 15 plus 1/6. Okay, we can cross multiply that. Minus 15 plus 1 over 6, that's equal to minus 6 plus 15 all over 6 times 15. That is equal to 9 over 90, and that equals to 1 over 10. So that's the answer to the first one. Just going to pause now and get the second one ready. Okay, so here's the second example, and we're asked to integrate 2x minus 1 all to the power of 4. Now, in this case, we have an indefinite integral. Okay. So we're going to use the substitution method again, and we're going to let u equals 2x minus 1. Okay, let's work that out. So du dx equals 2. So 1/2 times du equals dx, sort of like the last time around. So we can rewrite our expression as u to the power of 4 times 1/2 times du. So integral, we actually take the half out the front, such that we're just left with something rather simple like that. That is equal to 1/2 times u to the power of 5 over 5 plus c. or just putting back in the expression, or the 2x minus 1. So we have 2x minus 1 to the power of 5. So 1/2 and divided again, otherwise divided by 5, so that's just divided by 10 plus c. So that one's actually simple enough. It's an indefinite integral, so we don't have to evaluate it for any particular limits. So one last one for this presentation. Integral of x plus 1 over x to the power squared dx. Now, you might think, is this a good candidate for integration by substitution, the substitution technique? So we're going to try it out, but I'm just sort of giving a hint that it's actually not a good idea. So plus x over 1 of x. du dx, so that's equal to 1, and that's plus the log of x. I'm thinking, I don't know, that's a bit yucky looking. And you're right, so you don't get a nice, easy answer here. So essentially what I'm saying is that whole approach is wrong. But just consider this, that it's only to the squared. So it's not too hard to actually just, in this particular instance, just work it out fully. And in this case, if you multiply x plus a half, or x plus 1 over x, just multiply it out, dx, you get the integral of x squared plus 2 plus x to the power of minus 2 dx. And in that case, you can just sort of chop them up into little bits, which is say x cubed over 3 plus 2x plus 1 over x plus c. Now, essentially, that was once we decided to just actually work it out, multiply it out, it became a relatively simple problem. But again, the trick was, don't use substitution in this case. It just doesn't make for a nice answer. You saw we had 1 plus log of x or something like that. It just doesn't make for a nice answer. So if you have du dx equals 2 or 3 or something like that, and you see something that you'll cancel out with, fine. But if it doesn't, if you get a if it doesn't work, it doesn't work, and you have to try something else. Okay, we'll leave that one there.